Okay, I'm going to make another video where I try and combine series. So I'm starting with this differential equation, 3x y double prime plus y prime minus y equals 0. And notice that x is equals 0 is a singular point. You can either see that because the lead coefficient is 0, so it's going to be your denominator in P and Q, or if you actually write out that P and Q, we only have x raised to the first power in both cases, so x equals 0 would be a regular singular point. If x equals 0 was not regular, then we could not use this method. Okay, so in the previous video, I showed you what you would end up with for your y, y prime, and y double prime. So let's just start distributing things. When we distribute 3x times this, we're going to get a sum from n equals 0 to infinity. 3 times our constant times n plus r times n plus r minus 1. And then x times x to the n plus r minus 2, your power would go up by 1. So x to the n plus r minus 1. And then we have a sum from 0 to infinity. Nothing really changing here. Okay, so when we had ordinary singular points, our method was kind of a three-step process. First, distribute any polynomials or coefficients. Second, let k be the exponent that you see. And then third, make it so that all the series start at the same place, specifically in that order if possible. We are going to add one more extra step in here, which is I'm going to end up causing a lot of headaches for myself if I let k be this exponent, because then k is a function of both n and r, and so then cn would have to be somehow related to both k and r, which is going to be annoying. So before I do that, I want to deal with these r's that are showing up in the exponents. And so the way I'm going to do that is I'm going to factor x to the r out of absolutely everything. So still have coefficients with r's in them, but at least we won't have to worry about r's inside our exponents. Okay, and it's up to you if you want to write it at the front or the back. It doesn't really matter. Okay, now we do the same thing we normally do, which is let k be the exponent. So in this case, k is equal to n minus 1, which would mean n is k plus 1. And when n is 0, we're going to end up turning that into k is 0 minus 1, or k is negative 1. So we're actually allowed to start at a negative number. That's allowed. So I guess that'll be our starting point for the first series. So k equals negative 1 to infinity, 3 times cn, which is ck plus 1. N plus r would be k plus 1 plus r. N plus r minus 1. Actually, n minus 1, this part, is going to turn into a k. So we'll have k plus r. And then x to the n minus 1 is x to the k. Okay, the second series, k is going to be n minus 1 again. N is going to be k plus 1. And again, when n equals 0, k is going to be negative 1. And so we will have a sum, k equals negative 1 to infinity, c n, which is ck plus 1, n plus r, which is k plus 1 plus r, x to the n minus 1, which would be x to the k. And then minus the sum. This time we just have k is the same as n because that's the exponent that we're seeing. So k equals 0 to infinity, ck x to the k. Next up, we'd like to make all the series start at the same place. So 0, negative 1, and negative 1. We pick the largest value and try and make them all look like that largest value. So -1 and -1 are going to start one step before this one that starts at 0. So another way to think about it, all three of the series have a k equals 0 term, all three have a k equals 1 term, all three have a k equals 2 term, but only these ones have a k equals -1 term, so I need to factor that out or pull that out. So we'll write it as x to the r. Our k equals -1 term would be 3c minus 1 plus 1. Minus 1 plus 1 is 0. Minus 1 plus 1 plus r is r. And minus 1 plus r is r minus 1. So I've simplified a little bit, but this is my k equals -1 term. And then we have plus the sum of everything else. Since we just wanted to pull out one term, everything else is k greater than or equal to 0. Should be good to go. And that would be 3ck plus 1. I'll rewrite this one as k plus r plus 1. I like my variables before my constants. But otherwise, I'm just rewriting that. Okay, I'm going to pause the video. Again, I want you guys to practice. Take this one and try and do the same thing. Pull out a k equals -1 term. And plus everything else, k greater than or equal to 0. Okay, so just take this particular series and break it into two pieces. So I'm going to pause and let you try that. I'm back. The astute among you will have noticed that every time I pause and say, hey guys, pause the video and try something, there's a mistake on the stuff that I've already done. In this case, it was right here. This x to the -1 wasn't there. So when I actually plugged in k equals -1 into this, it should have been 3c0, -1 plus 1 plus r is r, -1 plus r is r minus 1, and then x to the -1. That's important. I completely missed it. It should have been there. So that should have been there. So if you want to try again, pause now and try and fix what should be here. But I'm just going to keep rolling. So if you take the second series and split it up, it should be these two pieces. So I guess let's make it a little more clear. This is the first series, this is the second series, and then I just copied the third series down as well, since it's not really changing at all. Okay, so staring at this one, when k is -1, c -1 plus 1, -1 plus 1 plus r, and x to the -1. Don't really have to change anything. And now if you look at the three sums, they all start at k equals 0. Okay, so we can put these two side by side. They both have x to the -1, so it makes sense to put them together. And then the three that are all in a summation, we can put those together. So I will do that next. So we have 3c0 times r minus 1, x to the -1, plus c0 times r times x to the -1, plus everything else is in a summation. So and they're all k equals 0. So let's just put a big sum k equals 0 and then write their insides. And actually I'm going to skip one more step. Well, yeah, let's skip one more step. All of them actually have x to the k. So let's factor out x to the k. So we're going to have x to the k times something. Okay, so we have 3ck plus 1. We have a k plus r plus 1. We have a k plus r. The x to the k we already factored out, so that's this term. Plus our second series, which is ck plus 1. K plus r plus 1. And then x to the k, which we already factored out. And then minus ck. And x to the k, which we already factored out. So close the big parentheses, close the bracket inside the summation, close this big bracket for everything that's multiplied by x to the r. Okay, so I have now successfully combined my series. I'm not going to bother messing with that r. I will just leave it out front, leave that x to the r out front. So I've now successfully combined my series. The only thing I might want to do is maybe combine these as a single x to the -1, which we could say that's 3c0 r r minus 1, x to the minus 1, plus c0r times x to the minus 1. Okay, so I'm not going to recopy this whole thing, but that would be the next step. That would be fully combine all the series as much as you can get them.